In the beginning of 2020, security researchers at Checkpoint Research reported a list of countless security vulnerabilities that they were able to find in the video sharing app TikTok. One of those vulnerabilities is something you might already know if you've been watching my other videos, and it's called cross-site scripting. But further adding to this, since they found out that XSS vulnerabilities existed, they were also able to find API endpoints that were vulnerable to so-called Cross-Site Request Forgery, or short CSRF attacks. By exploiting this vulnerability, attackers might have been able to perform actions on behalf of their victims, like deleting their videos, creating videos in their name, or make the victim follow other users or set a previously private video to public. But what exactly is a CSRF vulnerability, and how can attackers use it to perform those actions I just mentioned? In this video, you'll learn what CSRF is and how it works, how a CSRF attack is performed, and I will provide some countermeasures you can implement in your web application to avoid this vulnerability. What is CSRF? A cross-site request forgery attack is a vulnerability that allows attackers to make other web users perform actions without them knowing nor wanting to. Usually, the victim is completely unaware of the actions that are being performed on their user account until it's too late. In case of a successful attack, the attacker has many possibilities on what to do, depending on the functionality of the vulnerable web app. An attacker might be able to change the email address or the password on the victim's account, or other actions like those mentioned in the intro of this video. In the worst case, the attacker can fully overtake the victim's account. So, how does an attack like this work? First of all, there are 3 factors that are needed in order to perform a CSRF attack. To start, to perform a CSRF attack, the vulnerable web application needs to provide some kind of action the attacker wants to perform. We can't add any new actions to the application in a CSRF attack, so we have to use the ones the website already provides. For example, the option to change the email address of a user account, or sending money to another user. Anything that might be interesting to an attacker. The second factor is that the web application performs its session handling exclusively via cookies. This type of attack is also known as session riding, as the essence of a CSRF attack is performing HTTP requests using the victim's session identifier, in this case the cookies. Therefore, it is necessary that the web application uses those session cookies to determine the origin of a request. Last, it is necessary that the request the attacker wants to perform doesn't contain any additional parameters that are required to perform the action, but are impossible to guess. As an example, if the attacker wants to change the password of a user, but the password request requires the current password as a parameter, a CSRF attack is almost impossible to perform as long as the attacker doesn't know the value of this parameter. If all those requirements are satisfied, there are also a few steps involved in performing a CSRF attack. Those steps are the following. In the first step, the potential victim has to visit the vulnerable web page that contains the action the attacker wants to perform on their behalf. Once they're on their site, their browser has to establish an authenticated session with the page. This usually happens by the victim logging into their user account. In the next step, the user leaves the vulnerable page. It is important that the victim does not quit the authenticated session their browser has with the original website. Usually that happens when you log out of your account, but often people only close the page and don't actually log out of their accounts. This way, the session remains unchanged. In the last step, the victim somehow unintentionally performs a malicious request that was prepared by the attacker. An example on how that could happen could be this. After leaving the vulnerable page, the victim visits a website that was created or tampered with by the attacker. This page contains an HTML form that has hidden elements that contain the parameters needed for the malicious request. A button that is disguised as something else triggers the submit of said form, and the clueless victim clicks it. By submitting the form, the request gets sent out. Now, the cookies that your browser now sends out with that request are the ones it stored when the victim established the session with the vulnerable website from the first step. Now the request gets sent to said page, and since the cookies from the original connection are included, the website handles the request like it was actually from the victim. Now, if this explanation was a bit too abstract to you, the next part of this video will hopefully help you understand the whole concept better. So let's head into the demo and let me show you how a CSRF attack can look like. Alright, welcome to the demo part of this video. For this demo, I'm using the Portswigger Web Security Academy lab. Those labs are deliberately insecure websites provided to practice web security attacks on a legal basis. If you want to check it out yourself, I will put a link in the description of this video that will take you to the Cross-Site Request Forgery labs on the page. So this page has a My Account page, and on this page we have a function where a user can change their email address. Right now the address of the user logged in is wiener@normal-user.net. And Wiener is gonna be the victim of this attack today. As we can see here, we already checked off the first of the 3 factors that are needed to perform a CSRF attack, since the application provides the action we want to exploit. So in the first step, we changed the email to learn a bit more about the way the website performs this action. So we're just going to put just anything here, click on update email, and now we change the email of the user account. Now in the next step, we're going to open Burpsuit to get details on the request. If you want to learn more about Burpsuit, I put a link in the description where you can find more details on what this software can do. But right now we're just going to use the proxy tab with the HTTP history, because in this step we're just going to look for the post request that was made when we changed the email address. And right now we have it here. And first we can find out where the request is sent to, which is the host, aka the URL of the Web Security Academy lab, as well as the my account /change email. What we're going to do first is write down the URL to use it later. What we can do for this is do a right click in the request and just click on copy URL. So we got that, because we need that later on. Right below, we can also see that the web application uses cookies for its session management, which means we can also check it off the second factor needed for a CSRF attack. Now, all the way down, we can also find out what parameters are needed by the application to change the email address, and in this case, it's just the new email itself. This is great since there are no additional parameters needed, which means by now all 3 factors that are needed are given, and we can now start the CSRF attack. So in the next step, we create the HTML template that is needed for the attack. I've already prepared it, and this is what it looks like. So we have a HTML form that performs a post request to the target we just retrieved. And below that, we have an input field that contains the new value for the email we want to link the victim to. In this case, it's mail@veryevil.com. Since in this example, I'm playing both the roles of the attacker and the victim, the next step differs a bit from reality. We're using the exploit server that is provided by the application to send this new request, and this is this page here. In a real-life scenario, we would embed this HTML form somewhere in a web application with a very nice button the victim wants to click to submit the form. For example, we could put click here to win tickets to a Taylor Swift concert as the title of the button, and everybody would click it. Now, when the victim triggers the request and is still logged into the vulnerable page, the browser will automatically use the cookies from that session and use it for the request. This way, the vulnerable page thinks the request was sent from the victim and treat it as a normal request and change their email address. So in this example, instead of embedding the form in some page and hoping that anyone will click that, we're just going to use the view exploit button. Because since we're still logged in as Wiener in this browser, in the second tab, the session cookies matches Wiener's account. So I'm just going to click on View Exploit, and it takes us back to Wiener's account page, and we can see here that it says your email is mail@veryevil.com. So we were actually able to change Wiener's email address. So I hope this demo helped you understand the theory of a cross-site request forgery attack a bit better, despite the little workaround I had to use. Now, let's get back to the video, as you probably wonder what countermeasures can be implemented to prevent your web application being vulnerable to CSRF. Luckily, there are countermeasures that can be implemented when developing a web application that protects your site from this vulnerability and also protects your users. There are many more countermeasures to take into consideration, but for this video I want to focus on the following two. If you want to learn more about the other possible prevention measures, I will put a link in the description of this video that will lead you to the OWASP Cross-Site Request Forgery prevention cheat sheet, where you can find additional information. The first countermeasure you should think about using in your application is by using the same site attribute on the cookies that are being used by your page. Same site is a cookie attribute that defines if the browser sends the cookie along with a request that extends over multiple websites. There are different values that can be set for this attribute, like lax, strict, or none, depending on whether you want to exclude all external websites or allow subdomains and so on. Next, the most direct way to prevent CSRF attacks are so-called CSRF tokens that are generated on the server side. If implemented, any request that is sent to the backend server that doesn't contain such token will be rejected. Each CSRF token has to be unique, secret, and unpredictable. Depending on the functionality of your application, you can decide if those tokens are being generated once per session or if the user gets a new session token for every request. The latter is more secure, as they are only valid for a short amount of time, which makes it harder for an attacker to obtain such a token. Unfortunately, using a new token for every new request can result in some problems regarding the usability of your application. As I said before, there are a few more ways to prevent a CSRF vulnerability. Those include using custom request headers or determine if the origin of the request is actually your own application. I highly recommend the OWASP cheat sheet series to get detailed information on how to implement protection against countless web security vulnerabilities, including cross-site request forgery. To put everything together, I hope by now you have a good overview of what a cross-site request forgery vulnerability is and how hackers can exploit it to perform countless actions in the name of other users. By performing a CSRF attack, attackers can take over other user accounts by changing their email addresses or perform any other action the vulnerable application provides. As a normal internet user, I hope you now understand why it's always better to log out of your account before surfing to the next page, and why just closing the tab is always advised against. As a developer, I hope you learn to take this vulnerability serious and implement countermeasures like CSRF tokens and same-site cookies. You will find all the links to the resources and websites I mentioned in this video in the description. If you're interested in learning more about web security, consider subscribing to my channel so you don't miss out on any new uploads, and feel free to check out my other videos. Until then, I wish you a delightful day and see you soon in the next video. Goodbye.